After refraction, let it be like this. Green blue contrast is the problem. Take this. Yeah, fine. So there's an object. Time being, let me show, later on I'll bring that flower or any other object. Time being, just let me take the object, some vertical line here. So there's an objective lens, this is called as eyepiece lens. Focal length of this is called as objective lens. And this is eyepiece lens. This is a high. The person who there is eye only is what I'm showing here, this one. This is a human eye. So the rays, first they'll come here. There's an intermediate image. I1, H1. And there's a final image. Okay, these are the some set of diagrams we are taking here, no? This is an object which has to be viewed from the eye. Then I'll keep two convex lenses. The focal length of this is f0, this is f. You just go back to ray optics, nothing, you know, like, so definitely what happens, the objects, the image should be real, no? So what should be the focal length? The f0 will be here. There's object distance u0. And there's a focal f0 here. Go back to ray optics. Don't bother anything about the instrument now. Two lenses are there. I kept a object at a distance less than f0. Is it possible? The real image, this image I1 on the right hand, so no, it become virtual, no? So therefore, so what should be that f0 should come here. Okay, there's a minimum basic idea. There's the focal length of that objective lens. Write it f naught here. So if the object is between the f and 2f, what happens? The image will come on the right hand side of the lens, convex lens. So that image, so it will form an image I1. So this is thing. So what can be this distance? This will become v naught. This distance will become v naught. This image I1 now will become object for the eyepiece. For it to be virtual, this should be the focal length of eyepiece. So this is Fe. And this is VE. So sorry, this is UE and this is VE. The distances measured from objective, I'll write V naught, U naught. The distances measured from the eyepiece, I'll write VE and UE. It's not a thick length. The diagram appears like this. All the distances are measured from, again, the optic center. Either you measure from this surface, as it is a thin lens, no, doesn't matter. Okay, don't take it against a thickness you didn't consider. Okay, either you measure UV from here, this surface from the optic center, or here, both are same. According to the diagram, I'm just showing it here only, that one. Or it doesn't matter. In fact, it's a thin lens. In the diagram, I'm showing it a little bit thick. And the final image will be formed. Look at the final image. How do that final image is formed? Due to refracted rays, no? And these are diverging rays. And the final image is formed I2. Look at the height of this. This is what? H2, the final image. HI. and this is the object, that one. So that HI is greater than HO. Okay, it get magnified. Okay, now we have to bring expression for that magnifying power. I'm not talking about the magnification, the magnifying power here. So again, what is the basic definition for magnifying power? Angle subtended by the image, with the help of instrument at the eye to the angle subtended by the object at unaided eye, when it is kept at a distance of kept at a least distance of distinct vision. I think this is a generalized definition. So somewhere I think I should show that diagram here. And this is our unaided eye. So this now human eye, what happened now? It is taking help of this compound microscope, the two lenses. So therefore there's an aided eye. So there's the object H naught kept at a least distance of distinct vision. So this is what I think we took symbol alpha. So what is beta? Beta should come here. Oh, the diagram. H1 should come here. In that way, the rays. I'll adjust the things. This ray, okay. This ray, I should bend it. Yeah, fine. Okay, this is the thing. So this is that beta, which I'll define it. And there's a core diagram. So this what I suggest you like. First you draw the ray diagram. In the hand you bring lens. That's the easiest way of doing this problem. First what you should do, draw the ray diagram object h1, h2 all. Then what happen in the end, you put that lens, this curvatures. Don't draw first length and draw the ray diagram. First draw the ray diagram. In the end you bring the lens. You'll be in better position. There's one easiest way of drawing. So I think in board exam, there's a very famous question. Explain the compound microscope. Drawing diagram only students will, because you have to show all these things in order. You can't bring H1, like what earlier mistake I shown, no, should not happen. So therefore, first HO, H1, H2, then assume the ray diagram. Then in the end, you draw that curved surface, finish, or within 1 minute, you can wind up the diagram. Okay, this is about the basic thing. Now, what is this image? It can form at infinity or at least distance, no? Like there are two magnifications are there. Okay, let's get into the magnifying power of this compound microscope. What is the basic formula? So it should be equal to, I think I have space here. Let me write it. So what is the magnifying power? Angle subtended by the image at the high with the help of instrument, with the high which is taking help of instrument, to the angle subtended by the object at the unaided eye. So is it okay? Beta and alpha. Don't write alpha, beta in the same diagram. I think you might follow in the books what happened. They've just messed up everything. Alpha, beta, they're shown in the same diagram. There, I think the diagram will become very complicated. Just alpha, beta show in different diagrams for microscope. Finish out. So what is beta from the diagram? I think it's quite clear. No, look at this triangle. H1 by UE. What is alpha from this triangle? HO by D. Or this will become H1 by HO, D by UE. Now what is H1? H1 is this particular thing from come for this. So here we'll define this theta. So from tan theta, HO by HO by U naught, H1 by V naught. So H1 by HO, what we can write it? V naught by U naught. So therefore this will become V naught by U naught D by UV. This is the expression for magnifying power, not magnification. So now again the image can be formed where at the distance of least at the least distance of distinct vision or at infinity. Then what conditions will come? Is it okay? So this is a generalized thing. So now we are going to put it two cases. If the final image formed, if that I2 is at a distance of 25 centimeter from the eye, from that means this eye will be very close. In the diagram I shown, basically this eye will be somewhere located here. So what you measure the distance from the eyepiece lens or the eye will be same. Why it is called as eyepiece? Because it is near to the eye, human eye. Why it is called as objective? Because it's near to the object. The lens which is near to object called as objective lens. The lens which is near to eyepiece called as eyepiece lens. Fine. This is the first we'll go for. If the final image formed at distance of least distinct vision, that one. I think this the same diagram. I'll just write this capital D. This VE will become capital D here. What will be the magnifying power? I'll take the same diagram. Yeah, fine. Okay, this I'll write capital D. So now what is the thing? Compound microscope only. What is the condition? Final image I2 is formed at 25 centimeter. This one from the eye. And then what is this magnification power? Will become M25. That M25 is what we have to derive an expression for that. But what is the unknown thing? That UE is what unknown, no? That UE is what unknown. How to bring that UE? UE is what here, no? So how to bring that one? I'll go for this particular. What is the focal length of this? This eyepiece, no? FE. So what is the formula for this will be? 1 by VE. What is VE? VE will be minus D, minus 25. This is the minus UE, 1 by FE. So the entire formula will become now 1 by UE 1 by D plus 1 by FE. So magnifying power when the final image is formed at distance of least distinct vision, it is given by V naught, U naught, D by 1 plus D by 1 plus FE. So this will become M25 is equal to 1 plus D by FE. Okay, now you look at this. For simple microscope, we had this much of formula, no? The magnifying power of simple microscope is 1 plus D by FE. That is multiplied by V naught by U naught. So it's all about like if you make V naught by U naught 10 times. So the magnifying power of the like a compound microscope will get multiplied by 10 times of magnifying power of simple microscope. Here, what is this focal length of not objective of eyepiece? Able to get this? Look at this sign. Why? Because the final image will be, because the rays are moving towards right. So minus D. And what is capital D? Capital D is 25 centimeter. I think this by this time everyone should know. What is this? Least distance of distinct vision. If the object is kept at a distance less than 25 centimeter, the eye will feel strain. I can see, but lot of strain will be there. Means if this final image is formed here, like instead of here, if it is formed here, so what happened here? The eye, what happened, will encounter strain. Lot of strain will be there. You can't view it even for more than 10 seconds. Like I told you, bring mobile screen near to your eye at a distance of 3 or 4, 10 centimeter. You can see some sort of pain in your eyes. So therefore, there's a condition. The D, what happened? The distance of least distance of distinct vision, it should be 25. That's a universal rule. So like this, I'll get magnifying power. In fact, it will be negative. That negative sign I'm trying to avoid. In the diagram only, I'm showing the final image will be inverted. So what this human eye says is I'm seeing the image of that object at a distance of 25 centimeter from the eye, and it is inverted. I think no problem, even if it's inverted, because like a bacteria, how the bacteria will be there? Bacteria will be there like this, no? If it is inverted, no problem. It will not have nose, ears, nothing will be there, no? There's a bacteria will be like this. So if it is inverted, it doesn't matter, no? So therefore, the negative sign, though it is here in the actually numerical, it should come. I'm trying to avoid it because you'll get confused. In the diagram itself, I'm showing this. So what it says, the human eye, what it says, I'm seeing magnified image, inverted image. I'm seeing magnifying power for M25. I'll write directly M25, that one. So there's a formula like. What is the length of the tube? So shall we take this is the length of the tube. What do you mean by length of the tube? The distance between the objective and eyepiece. That's called like a length of the tube. Let me write L25. What is L25 should be equal to? I think it should be V naught plus UE, no? Able to see this distance. You have to measure from here to here. So what is the distance? This will be V naught plus UE. So what is the length of the tube will be? Now what is UE is equal to? UE should be equal to DFE by D plus FE. V naught is unknown, which we have to calculate here. This is what length of the tube we call microscope tube. So what is this one? Distance between objective and eyepiece is called as the length of the tube and is equal to this much. Don't substitute this negative sensor UV negative. No, the distance is what we are calculating V naught plus UV. It's a if you are getting confusion, go for mod. He's asking that length, no, the distance. Fine. So this is about the thing that one. What actually happening here means okay, sir, fine, everything. You are given equations all. What actually going on? So let's keep some specimen. I think in for microscope we'll call specimen. No, what is the name? We'll give. We'll call that as a specimen. Let me send it here. I'll give only rough ray diagram. I'll not give only that. So this is the objective lens. This is eyepiece. Here what happened? We have kept some, say, like a specimen. What is the specimen? It will be insect. It will be some cell or something. Okay, now coronavirus. Let me keep it here. How coronavirus? Shape is there, no? Some. Okay, that one. Very difficult. I'll do one
Hello.
thing. I'll just. Please mute it. No, lot of disturbance is coming. Let me take cockroach. Huh? Let me take some small insect because coronavirus. I am also scared of it. Let's take this one. It is like this. Huh? So this is that specimen. There's the objective F naught. This is Fe. How do it will appear? It will appear bigger in size. I think. Okay. This is what happens to it. So there's an object, there's an insect, real insect, and the human eye is here. So what this this eyepiece, nothing big. Just you have to understand this basic condition. The intermediate image you'll not see. Actually, it's not correct to show that I1. Only you have to show that there's an object, there's an image, there's a final image. So it is at a distance of 25 centimeter. It is formed. You can decide where it should be formed. Okay, let's go for theoretical condition, 25 centimeter. This is the final image. Okay, now the high what it say, I am seeing the big insect. I am able to see all the 3 legs are there, 2 eyes are there, antenna, then here some tail, like this, that's what it says. So this what happens for us here now, a magnified one. So more details, no, definitely I'll ask you like here how many dots are there. So 6 dots, so that they are very clearly visible in the magnified image, no? So how many dots are there means the eye cannot tell very clearly looking at the insect. Now this magnified image, yes, we are able to see all things clearly, very clearly that one. That's what advantage with the compound microscope. The what is the magnification? It come 300, 400, 500 of that order. Such a high magnification is being produced. So what all that object is done, it will appear 300 times bigger. So that line one, you come out of that one. It should be like the overall, the dimension of object will increase. Simple microscope, it can produce magnification of order few tens, whereas this is will produce compound microscope will produce magnification of order few hundreds, 300, 400, 600. Okay, fine. So this I didn't draw a ray diagram. Just I showed later on. After the class when I'm posting, I'll color it. I'll send it to you, so that will be still more easier for you. So this is about the magnifying power when the final image is formed at the distance of least distinct vision. I think this was the thing, no? Final image I2 is formed at 25 centimeter from the eye. No, if final image is formed at infinity, because look at the eye, you ask the eye, okay, are you viewing it comfortably? It will say, okay, that one. If the rays enter parallelly into the eye, then what when the eye will feel very comfortable. You look at the try to view the far away objects from your home, no, through window, try to see some far away objects. You can view it for longer time. The reason the rays are entering parallelly into the eyes. Nothing but if the object is far away, if the rays enter parallelly into the eye, what happen? You can view it for longer time. Now, what shall I do now? So I'll do adjustment. I'll do adjustment. I'll adjust the U naught and the distance between the lens in such a way that the rays here, what happen after refraction here, they'll become parallel. Then where the image will come, image will be at infinity. Image at infinity means don't think that I cannot see. You look at the far away object. Look at the far away, some tree or some hill or some any building. I don't think so. Any mountain you can see in Hyderabad city. So any some far away building, or if you see some far away trees, so there the rays coming from them are like a parallel. The same thing happens. The rays, what happen if they become parallel? I can view it for longer time, and where the image will be at infinity. Okay, tell me like how the overall system will appear. Overall, how this system will appear. So I will take the same diagram, little bit modification will do it. Books, that's what is the difficulty in the books? What happened? Alpha and beta put in same diagram. Huh? That's a really very complicated it is. Huh? We'll push it down. Yeah. Now this is the thing. Little bit small. I'll make it. Yeah. Now final image at infinity. So what changes are to be brought here? After refraction, the rays should become parallel. If the rays become parallel, so we'll just change these things. Okay, are you able to see this? The rays they'll become parallel, and you are not going to show this where the image will be now. Image will be at infinity. Now the length of the tube, I'll use word still infinity only. So it's not like infinite length. The distance between object and eyepiece will be non-zero still, that one. So where is the image, I'm seeing magnified and inverted image very comfortably. I will further, he will put a one more comment. What is the one more comment? Hind very comfortable. Earlier it was only magnified and inverted image. Now magnified, inverted image, and very comfortably. Why very comfortably? Because the rays will enter now parallelly. Final image I2 is formed at What is the magnifying power in this case? So m infinity, again, the definition stands same. What should be UE should be equal to? This can happen when only when this is at focal length, no? If the image I1 is formed at the focal length of eyepiece, then what will happen to the rays? After reflection, they'll become parallel and the image will be formed at infinity. I'll pull this rays back like this. Means, sir, image at infinity, can we see? I think now you get back to the original idea. What is that? Rays coming from far away, how do they enter into eyes? Parallelly. This is the core idea, that one. You can see the moon also, no? Where is the moon? In Karnataka or in Kerala or in some Pakistan? Where is the moon? Moon is some outside the earth, no? Far away. And we are able to see it comfortably. The reason for the rays emitted by the moon, radiation open, they enter parallelly. So are we able to see as that one? The same thing. The rays will enter parallelly and the eye will say that I'm able to see this H naught. But sir, where is H2? You can ask it. It is at infinity. Sir, though it is at infinity, how you are able to see? Is it the rays entering into the eye or not? As the refracted rays enter into the eye, I'm able to visualize that image. Okay, let's see what is the magnifying power. So what is UE should be equal to? I think the entire discussion is the UE will become equal to FE. There's a magnifying power. V naught by U naught, D by FE. Because what is value of UV? UV will become equal to FE. Which case magnifying power will be more. When object is at 25 centimeter, that called like a near point. So actually, if you see the books, now some books they also called it like a final image at near point. Final image I2 at 25 centimeter from the eye, or we can also call it as a near point. Eye, or what is the nearest point at which we can see the object clearly? 25 centimeter. This is called like a near point. So what is this condition now? Final image I2 at infinity or far point. What is the farthest point? Infinity. Then what is the magnifying power in this case? V naught by U naught, D by FE. So what is the length of the tube? Length of the tube should be V naught plus mod of UV. What is UV? Should be equal to FE. This is the length of the tube. And the same thing, the same cockroach, now what happened? I don't think that infinite image. Look at M infinity. Is it infinity? No, some finite value, no? It's some finite value. So it will appear like it will appear bigger. Even for this also the same diagram. But you should not show this. Where this will be? This will be at infinity. That's what I'm trying to avoid. If the rays will come parallelly, where we have to show, this will be at infinity. It will be there, but it will be visual. It will be visible for us. Next, another question. So can we have a situation where this final image, can it be here? Yes, it can be a location of here. It can be here. It can be here. Okay, got this one. So it can be anywhere here. So some books open, they shown the final image will be here. That doesn't matter, sir. It all depends upon the values. So this diagram is for what? Final image at near point. For far point, okay, just we'll keep only this one. Okay, this is overall the magnifying power and the length of it. These are the only two things what it's there in microscope here. Okay, shall I go for next telescope? Problems will do combinedly. Some two problems are there. Very easy for you. I'll start the telescope. What is a telescope? I want to see the far away objects. There's a one basic necessity condition. So when I'm considering, so what is the object now? In case of microscope, where do you keep the cockroach or that particular thing, insect? Will you keep it moon and then watch? Okay, some of you are asking question. Tell me like you are using microscope. This is a specimen, no? Okay, where do this insect will be there? The insect which is there in the moon, you are going to view by microscope, not like that, no? Okay, this diagram. At what distance the specimen will be? At a distance of u naught. There's an object, there's an image. This will be. So the object is at finite distance from the objective lens. That's what happens in compound microscope. Now, what is a telescope? It's an instrument which is used to view objects which are far away, like terrestrial objects, like heavenly objects, like a